A circuit has a real power of 1.5 kilowatts and a phase angle of 40 degrees. So they've given us theta this time. And I think I am going to draw the colored lines on this one because we're dealing with, I think, a trig ratio. Find the apparent power. So we're looking for this one. All right, so since we're dealing with a ratio, let me put those lines in for you, or for me. So here is opposite, because remember, everything is from the perspective of theta. And then we have adjacent, because it's touching theta. And that is, let me just put the word down here. And then, of course, hypotenuse. That one was always, for me, the easiest one to recognize because I've dealt with it so much in life. And that is hypotenuse. Okay, and we know theta, so we're dealing with a ratio this time. We're looking for apparent power. We're looking for hypotenuse. If we knew opposite, we could use Pythagorean theorem, but we don't, so we're going to have to rely on some trigonometry or some form of a ratio, a relationship. So let's review. So, ka, toa. And let's figure out which one of those is going to benefit me here. So I know, let me write it this way. I know adjacent. That is 1.5. I want to know hypotenuse. So I want to know the one of these that relates or gives me information about A and H. And that is going to be cosine. The cosine ratio says the cosine of theta is equal to adjacent over hypotenuse. So the cosine of theta, that's 40, is equal to the adjacent over the hypotenuse. So we need to get rid of the h on the bottom here. So let me do brackets and put h over here. So I'm left with h cosine 40 is equal to 1.5. So I'm going to divide by the cosine of 40. And that will leave me with an h, or hypotenuse. And this is one of those that I need a scientific calculator, so I'm going to do 1.5 divided by the cosine of 40. And that is clearly not right. Let me get my scientific calculator out here. And I'm going to need, sorry, bear with me 1 second. 1.5 divided by the cosine of 40 equals about 1.96 is the apparent power. And remember, we do have kilo involved here. That is one of the few times we've used cosine. just to remind you, this is completely unrelated to this problem, but power factor can also be expressed as the cosine of theta. So if you wanted to know the power factor of this triangle, you would do the cosine of 40, which happens to be part of what we just found. Power factor would be, get my scientific calculator again, cosine 40 is equal to 0.77 approximately. So you can use that cosine feature to find power factor if you know theta. I don't see cosine often, so I wanted to show you that. All right, number 20. A circuit has an apparent power of 750 and a power factor of 0.8. Find the reactive power. So we are looking for this number. Don't know theta, so we can't find the missing side using trig ratio. So we're going to have to rely on Pythagorean theorem. But before I do that, I'm going to use this power factor formula that I know to be W over apparent power. So 0.8 equals W over 750. So I'm about to find W, which will definitely help me in the next step. So let's do 750 times both sides. And 750 times 0.8. 750 times 0.8 is 600. So 600 equals W. That's this number. And now I have set up Pythagorean theorem. So a squared plus b squared is c squared. For the power triangle, C is your VA. B is either W or VAR. And A is the other. So 600 squared plus reactive squared is 750 squared. And we have some math to do here. 6 to the second power is 36 with 4 zeros. We don't know reactive yet. And then 750 times 750 is 562,500. So we will subtract this one from both sides and cancel. And so I'm left with reactive squared equaling 202,500. Take the square root of both sides. So reactive power is, I believe that one's going to be an even one, but let me look. I believe that's a perfect square. Possibly not. Yes, it's 450. So the reactive power is 450. And this was not in kilo units, so just 450.